You are being lied to. Right now. Wow. Constantly. And the liar is someone you trust completely. It is not the news. It is not social media. It is not politicians or advertisers, or that friend who always exaggerates. The liar is you. This is not an insult. This is not a judgment. This is a fact about the architecture of your mind. And here is the unsettling part. The smarter you are, the more educated you are, the more sophisticated your thinking becomes, the better you get at lying to yourself without ever noticing you are doing it. Richard Feynman, perhaps the most brilliant physicist of the 20th century, spent years thinking about this problem. He won a Nobel Prize. He helped build the atomic bomb. He decoded the mystery of quantum electrodynamics. But when he stood before a crowd of graduating scientists at Caltech in 1974, he did not talk about any of that. Instead, he delivered a warning. And that warning was this. The first principle is that you must not fool yourself. And you are the easiest person to fool. Stop, Darren. Think about that for a moment. The easiest person to fool is not your neighbor. Not your student. Not the stranger on the internet. It is you. Feynman was not being pessimistic. He was being honest. And in that honesty lies one of the most important ideas in the history of science. Science is not a collection of facts. It is not a pile of equations. It is not the textbooks gathering dust on shelves. Science is a method, a way of thinking designed specifically to overcome the limitations of the human mind. For thousands of years, humans looked at the sun moving across the sky and concluded reasonably that the sun orbited the earth. They felt the ground beneath their feet standing perfectly still and concluded, reasonably, that the earth was not moving. They watched heavy objects fall faster than light ones and concluded, reasonably, that weight determines the speed of falling. Every single one of these reasonable conclusions was wrong. The universe does not care what seems reasonable to you. The universe does not care what feels right. Your brain did not evolve to understand quantum mechanics. It did not evolve to grasp the curvature of space-time. Your brain evolved to help your ancestors survive on the African savanna, to spot predators, to find food, to navigate social hierarchies. Your brain craves certainty, but the universe offers only probability. Your brain sees patterns everywhere, even in randomness. Scientists call this confirmation bias, but that clinical term does not capture the full horror of the situation. The only thing you can do is design systems that work against it. And that is exactly what science is supposed to be. To understand what Feynman was warning us about, we need to travel to the South Pacific during World War II. Picture a remote island, untouched by modern technology, suddenly transformed into a military airstrip. American soldiers arrive. They clear runways. They build control towers. They set up radio equipment. Not in South. And then something miraculous happens. Cargo planes descend from the sky. These metal birds, larger than anything the islanders have ever seen, land on the runways and disgorge treasures beyond imagination. The indigenous people watch carefully. They observe the patterns. They see soldiers sitting in towers wearing headphones. They see men with paddles waving their arms in specific sequences. They see the runways kept clear and fires lit along the edges. Then the war ends. The soldiers leave. The planes stop coming. So the islanders, using pure logic, decide to bring the planes back. They clear strips of land to create runways. They build control towers from bamboo. They carve headphones from wood and wear them while sitting in the towers. They fashion antenna shapes from straw.u. Men stand on the runway, waving palm fronds in the same patterns they had seen the soldiers use. Every element is replicated with stunning attention to detail. The form is perfect. The planes never come. Now, before we laugh at these islanders, before we dismiss them as primitive or foolish, consider what they were doing. They were being empirical. They observed a phenomenon. They identified apparent correlations. They formed a hypothesis about cause and effect. By the standards of naive observation, they did everything right. But here is what they were missing. They had no understanding of radio waves. They had no knowledge of flight mechanics. They had no concept of military supply chains, geopolitics, or the industrial infrastructure. They had copied the visible form without understanding the invisible substance. To an outside observer, their airstrip looked exactly like the real thing. To the planes that never came, it was meaningless. Feynman stood at that Caltech podium and told those graduating scientists that they were doing the same thing. Not with runways. With science itself. You know what I mean? Feynman was not attacking pseudoscience. He was not talking about astrology or crystal healing, or the latest wellness fad. He was exposing something far more uncomfortable. He was pointing at research published in respected journals. Studies taught in university courses, work funded by major institutions and cited by other experts. Science that looks legitimate, follows all the rules, and still gets reality wrong. He called it cargo cult science. Cargo cult science follows all the apparent precepts and forms of scientific investigation. It uses statistics. It undergoes peer review. It gets published. It gets citations. It looks on the surface indistinguishable from real science. But the planes never land. The predictions fail to replicate. The effects disappear when tested by independent researchers. The theories, when pushed, turn out to be vapor. So what is missing? What is the difference between the bamboo control tower and the real thing? Feynman identified it as a kind of scientific integrity, a principle of scientific thought that corresponds to a kind of utter honesty, a kind of leaning over backwards. Imagine you are doing an experiment. You get a result that confirms your hypothesis. What do? If you are practicing cargo cult science, you publish. You have your result. It matches what you expected. The statistical tests pass. Why would you do anything else? But if you are practicing real science, if you have genuine scientific integrity, you do something different. You stop. You ask yourself, how could I be wrong? You report everything that might make your result invalid. You list other causes that could possibly explain what you observe. You bend over backwards to give other scientists the information they need to prove you wrong. This is not natural. This is not how humans typically behave. Every instinct in your brain screams against it. You worked hard on this research. You believe in your hypothesis. You need to publish to advance your career. You want to be right. And here is this principle demanding that you actively help your critics dismantle your work. Let us look at a specific example that Feynman himself used, one that cuts to the heart of how even brilliant scientists at the highest levels of physics can fall into the cargo cult trap. Robert Millikan performed one of the most famous experiments in the history of physics, the oil drop experiment. By watching tiny charged droplets of oil suspended in an electric field, he measured the charge of a single electron. This was groundbreaking work. It earned him the Nobel Prize in 1923. But there was a problem. His value was slightly wrong. As subsequent physicists tried to replicate his work, they kept getting values slightly different from Millikan's. Each researcher would perform their measurement, get a number, compare it to Millikan's prestigious result, and notice a discrepancy. What did they do? They assumed their own methodology must be flawed. After all, Millikan was a Nobel laureate. His experiment was famous. His result was in all the textbooks. Who were they to contradict it? So they would adjust their procedures. They would fiddle with their analysis. They would publish a value closer to Millikan's. Nice. Then the next researcher would do the same. And the next. And the next. For years, the scientific community slowly crept toward the correct value through this chain of partial self-deception. Each physicist thought they were being rigorous. Each followed proper experimental protocols. Each had good reasons to trust Millikan's earlier work. But collectively, they were practicing cargo cult science. They had the form of verification without the substance of genuine independent testing. They were unconsciously tuning their results to match expectations rather than measuring reality cleanly. The harm is that this pattern scales. It infects entire fields, minds. It corrupts the foundation of knowledge. When scientists unconsciously anchor their results to previous expectations, when they smooth over discrepancies instead of investigating them, when they publish only the results that look clean and bury the ones that do not make sense, something terrible happens. The errors compound. The field drifts away from reality. And nobody notices, because everyone is checking their work against everyone else's contaminated work. This is exactly what happened in psychology for decades. Entire research programs were built on findings that later turned out to be unreplicable. Theories taught in textbooks collapsed when subjected to genuine scrutiny. Studies cited thousands of times evaporated when independent researchers actually tried to verify. Feynman saw this coming 50 years before the replication crisis made headlines. He was warning about it in 1974. Almost no one listened. Feynman told another story in his speech, one that perfectly illustrates the difference between cargo cult science and the real thing. In the early days of behavioral psychology, researchers would run rats through mazes. They would train a rat to find food, then change something about the maze, and measure how the change affected the rat's behavior. Thousands of these experiments were published. They formed the foundation of an entire field. But there was a problem. The experiments were not replicating. Different laboratories would run the same experiment and get different results. Nobody could figure out why. Then a researcher named Young decided to take a different approach. Instead of asking what the rats were learning, he asked a more fundamental question. How are the rats actually navigating? He ran a series of meticulous experiments. He discovered that rats were using cues that no one had considered. They could smell the food through the apparatus. They could see the lights in the laboratory. They could feel tiny vibrations in the floor. Young systematically removed each cue, one at a time, watching what changed. He painted the maze to eliminate visual cues. He used chemicals to mask smells. He covered the corridor. He controlled for every variable he could think of. And he discovered all the things you have to do to actually run a valid rat experiment. But here is the tragedy. His papers were not referenced. His work was ignored. He did not discover anything about rats, so the scientific community dismissed him. But in fact, Feynman pointed out, he discovered everything you have to do to discover something about rats. He found out what variables actually mattered. He laid the groundwork that would make all subsequent rat research meaningful. The cargo cult scientists ignored him. They continued running their experiments without proper controls. They continued publishing results that looked scientific, but were not. Feynman gave one more example that should chill anyone who cares about truth. Consider the history of parapsychology research, the scientific study of psychic phenomena like extrasensory perception. For decades, researchers like J.B. Rhine at Duke University ran experiments claiming to demonstrate that some people could perceive information through channels unknown to science. Now, here is what makes this interesting. As various critics pointed out methodological problems with the experiments, the parapsychologists, to their credit, would improve their techniques. They would add better controls. They would tighten their protocols. They would eliminate potential sources of error. And a strange thing happened. As the experiments got more rigorous, the effects got smaller, and smaller, and smaller, not until they eventually disappeared. If ESP were real, better experiments should detect it more reliably, not less. But instead, each improvement in methodology caused the effect to shrink, as if the phenomenon only existed in the gap between sloppy measurement and rigorous testing. Eventually, the parapsychologists were reduced to arguing that it is an irrelevant demand to expect a repeatable experiment. They had abandoned the core principle that distinguishes science from storytelling. Feynman asked, "Is this science?" The answer obviously is no. But the question is not about parapsychology. The question is about how many fields, right now, might be making the same mistake. How many effects published in respected journals might be living in that gap between sloppy and rigorous methodology? How many theories might shrink to nothing if someone actually tried to verify them properly? But here is where it gets truly uncomfortable. You might think that cargo cult science is a problem of ignorance, that if we just train scientists better, if we teach them about confirmation bias and proper methodology, the problem will solve itself. Feynman knew otherwise. The problem is not just individual psychology. The problem is systemic. The institutions of science actively reward cargo cult practices. Think about how modern science actually works. Careers advance based on publications. More papers mean more success. To publish, you need results. Not null results. Not failed replications. Not messy, ambiguous data. You need positive findings, clean narratives, statistically significant effects. Funding agencies want promising preliminary results before they will give you money to do more research. Journals want novel, exciting findings, not careful replications of previous work. University administrators want grant dollars and publication counts, not careful, slow, meticulous verification. The entire system is structured to reward exactly the kind of work Feynman warned against. Real science is messy. It is full of uncertainties and contradictory data and results that do not make sense. Papers that honestly report all that messiness often look weaker than papers that smooth over the complication. So what happens? Scientists, consciously or not, learn to produce cleaner narratives. They learn to present their work in ways that fit the expectations of journals and funding agencies. They learn to emphasize the positive and downplay the negative. They learn to practice cargo cult science. Not because they are dishonest. Most cargo cult scientists are completely sincere. They genuinely believe they are doing real science. The self-deception runs so deep that they do not notice they are doing it. Imagine for a moment that you are a researcher. You have spent 3 years on a study. You have a hypothesis you believe in deeply. Your career depends on getting published. Your mortgage payment depends on getting your next grant. You run your experiment. The results are ambiguous. Some measures show the effect you predicted. Some do not. Money seen as shines it choose. The overall pattern is complicated. What do you do? If you have genuine scientific integrity, Feynman says, you report everything. You describe the measures that failed. You discuss alternative explanations. You highlight the ambiguities. You give other scientists the information they need to show you it might be wrong. But if you do that, your paper looks weak. The reviewers will have doubts. The journal might reject it. Your grant might not get renewed. Your career might stall. Or you could do what everyone else does. You could emphasize the positive findings. You could run your analysis slightly differently in a way that makes the effect look cleaner. You could leave out the measures that did not work. You could craft a compelling narrative. You are not lying. Everything you report is technically true. You are just presenting your work in the best possible light. Everyone does it. Your mentors taught you to do it. The system expects it. But you have crossed a line. You have started building a bamboo control tower. So what is the solution? How do we practice real science in a system that rewards fake science? Feynman did not have an easy answer. He admitted it would be about as difficult to explain to the South Sea Islanders how they have to arrange things so that they get some wealth in their system. It is not something simple like telling them how to improve the shapes of the earphones. But he did offer a principle. A first principle. A foundation on which everything else must be built. You must not fool yourself. And you are the easiest person to fool. This is not just a warning. It is a prescription. It tells you where to direct your skepticism. Most people think critical thinking means being skeptical of others. Questioning experts. Doubting authority. But Feynman is saying something different. He is saying your most important job is to be skeptical of yourself. When you believe something strongly, that is when you need to be most careful. When evidence supports your hypothesis, that is when you need to look hardest for flaws. When everyone agrees with you, that is when you need to worry most. The instinct is exactly backward. When we feel certain, we relax our guard. When evidence confirms our beliefs, we feel validated. When others agree, we feel confident. But certainty, confirmation, and consensus are precisely the conditions under which self-deception flourishes. Imagine you are holding a theory you believe is true. You have evidence for it. Other smart people agree with you. Meaning, everything seems solid. Now ask yourself, what evidence would change my mind? If you cannot answer that question, You do not have a scientific theory. You have a belief. You have something that looks like knowledge but functions like faith. Real theories make predictions. They stake out territory in the space of possible observations. I mean, they say, if my theory is true, we should see this. If we do not see this, my theory is wrong. Cargo cult theories are different. They are flexible. They can absorb any evidence. When the predictions fail, the theory adjusts. When the effects disappear, the goalposts move. The theory becomes, in the words of one sociologist, more vampirical than empirical, unable to be killed by mere evidence. This is not science. This is storytelling that has borrowed the vocabulary of science. Now this might all sound depressing. We are wired to deceive ourselves. The systems around us reward self-deception. Even the smartest among us fall into the trap. But here is where Feynman's message takes a surprising turn. There is something beautiful in doubt. Think about what it means to truly embrace uncertainty. It means being open to learning. And it means being capable of change. It means staying connected to reality, rather than retreating into comfortable delusions. The person who is certain has stopped growing. They have locked themselves into a position. They have built their bamboo control tower, and now they must defend it, no matter what. The person who embraces doubt remains alive to the universe. They can update their beliefs. They can notice evidence. They can change direction when reality demands it. This is not weakness. This is the greatest intellectual strength a person can have. Feynman spent his career reveling in uncertainty. He delighted in not knowing. He approached physics not as a body of established facts, but as an ongoing adventure of discovery. He was wrong constantly, and he loved being wrong, because being wrong meant learning something new. I would rather have questions that cannot be answered than answers that cannot be questioned, he said. This is not a slogan. It is a way of life. Here is a thought experiment that might change how you see the world. Think of something you believe strongly, something you would defend in an argument, something that feels like part of your identity. Now imagine discovering tomorrow that you were completely wrong. How does that feel? If it feels threatening, if it feels like an attack on who you are, then that belief has become dangerous. It has stopped being a map of reality and started being a piece of your ego. It has become something you need to protect rather than something you use to navigate. Feynman's principle requires courage. It requires the willingness to be wrong publicly. It requires admitting that something you spent years defending was mistaken. It requires giving up the certainty that makes life feel safe. But here is the reward. The reward is reality. The reward is actually knowing things, rather than just feeling like you know things. The reward is building on solid ground instead of bamboo. So what does scientific integrity actually require? Feynman spelled it out clearly. When you publish an experiment, you should report everything that might make it invalid. Not just what you think is right about it, but every alternative explanation, every potential flaw, every ambiguity. When your theory makes a prediction, you should try to falsify it, not confirm it. You should design experiments that could prove you wrong. If your theory keeps surviving these tests, then maybe it is onto something. If it keeps requiring adjustments and exceptions, be suspicious. When you get a result, you should check whether you would have found it if you had been trying to find the opposite. If your methods would have given you a positive result either way, your methods are useless. When you build a complex theory, you should make sure it predicts things beyond what gave you the idea for it. If your theory only explains what it was designed to explain, it might just be a story dressed up in scientific language. This is hard. This goes against every instinct. But this is what separates the real airstrip from the bamboo one. Now, Feynman was talking about science, but his principle applies far beyond the laboratory. Cargo cult thinking appears everywhere. In business, where companies follow the visible practices of successful firms without understanding what actually made them successful. In education, where students memorize definitions and formulas without grasping the concepts behind them. In journalism, where the appearance of balance substitutes for actual investigation. In policy, where the trappings of expertise mask fundamental uncertainty. Every field where people claim to know things is susceptible to the same trap. Think about the experts you trust. They cite sources. They use proper terminology. They have credentials. Every marker of legitimate expertise is present. But are they practicing cargo cult expertise? Are they selectively presenting evidence that supports their preferred narrative while burying contradictions? Are they mistaking the appearance of rigor for actual rigor? This is not a call to dismiss all expertise. That would be its own form of foolishness. But it is a call to ask the uncomfortable questions. To notice when experts never seem to admit uncertainty. To wonder when predictions keep failing but confidence remains high. To be suspicious when the answer is always conveniently aligned with the interests of the answerer. Here's the hardest question of all. How do you know if you are a cargo cult thinker? By definition, if you are fooling yourself, you do not notice you are doing it. The self-deception is invisible from the inside. Feynman struggled with this himself. He told a story about his own early research, where he got excited about a result only to realize later he had unconsciously nudged his analysis in the direction he wanted. If Richard Feynman, with all his brilliance and self-awareness, fell into this trap, what chance do the rest of us have? The answer is, not much. Not on our own. This is why science is a social enterprise. Not because scientists are individually trustworthy, but precisely because they are not. Science works, when it works, because researchers check each other. They replicate experiments. They criticize methods. They point out the flaws that the original researcher could not see. The system requires critics. It requires people willing to say, I tried your experiment and it did not work. It requires publishing negative results and failed replications. It requires rewarding people who find errors, not just people who find effects. But here's the problem. Remember what happened to Young, the researcher who figured out how to actually run rat experiments? His papers were ignored. He discovered something essential, and the scientific community dismissed him because it was not a new result. The system, as currently structured, does not reward the people who make science actually work. Feynman ended his speech by presenting the graduating scientists with a choice. They could play the game. They could practice cargo cult science. They could publish clean-looking papers with strong-seeming conclusions. They could follow the incentives, gather citations, build careers, and achieve conventional success. Or they could practice real science. They could publish less. They could struggle for funding. They could be seen as difficult or uncooperative. They could spend years on careful verification that never makes headlines. They could possibly never achieve conventional success. He could not tell them which to choose. He could only explain what each path meant. One path leads to a career built on bamboo. The other leads to genuine understanding, at whatever cost. Step back for a moment and consider what Feynman is really saying. He is saying that the human mind, left to its own devices, drifts toward delusion. That our natural mode of thinking is not truth-seeking but comfort-seeking. That we construct elaborate justifications for what we want to believe, and call it reasoning. This is not a flaw in some people. This is a feature of all people. You, me, the greatest scientists in history. Everyone. And yet somehow, despite this, we have discovered actual truths about the universe. We know about atoms. We know about evolution. We know about the age of the cosmos. We have touched the moon and photographed black holes. How is this possible? How can deeply flawed minds arrive at genuine knowledge? The answer is method. Specifically, a method designed to counteract our flaws. Science is not a collection of facts. Science is a set of practices that force us to notice when we are wrong. It is a systematic process for catching self-deception. It is a culture of criticism and verification and doubt. When science works, it is not because scientists are unusually honest. It is because the structure of science demands honesty, even from people who would rather not provide it. But the structure only works if we maintain it. If we let the incentives drift toward rewarding appearance over substance, if we stop replicating, if we stop criticizing, If we let the bamboo towers stand unchallenged, then we lose the whole thing. We go back to fooling ourselves. We go back to the comfortable delusions our brains prefer. We go back to the cargo cult. So where does this leave us? Not with answers. Feynman would be suspicious of anyone who claimed to have all the answers. But with a practice, with a discipline, a way of engaging with the world that takes seriously the fundamental unreliability of our own minds. It starts with doubt, not cynical doubt that dismisses everything. When the doubt dismisses everything, but productive doubt that asks, how might I be wrong? What would change my mind? Nice, idea. Am I seeking evidence or just confirmation? It continues with honesty. Honesty about uncertainty. Honesty about limitations. Honesty about the difference between what we know and what we merely believe. It requires courage. The courage to say, I do not know. The courage to change your mind publicly. The courage to value truth over the appearance of certainty. And it demands humility, the recognition that you are exactly as susceptible to self-deception as everyone else. The willingness to subject your most cherished beliefs to the same scrutiny you apply to ideas you dislike. This is hard. This goes against instinct. Most people will not do it. But for those who do, there is a reward that Feynman understood better than anyone. The universe is more interesting than your fantasies about. Reality, when you finally touch it, is stranger and more beautiful than any story you could have made up. The joy of discovery, of actually knowing something that turns out to be true, is deeper than any comfort delusion could provide. Feynman experienced this joy his entire life. He described the beauty of a flower that grows when you understand the biology and chemistry and physics behind it. He talked about the pleasure of finding things out, of moving from confusion to clarity. This pleasure is available to anyone willing to do the hard work of not fooling themselves. There is something poetic about Feynman's message. He spent his career at the frontier of human knowledge, grappling with the most fundamental questions about the nature of reality. He worked on problems that most people cannot even articulate. And yet his most important advice was simple. So simple that a child could understand it. Which is so true, and said, do not fool yourself. You are the easiest person to fool. This is not a statement about science. This is a statement about what it means to be human. We are creatures who deceive ourselves constantly. We construct narratives. We build mental models. We convince ourselves of things that are not true. And the only antidote is eternal vigilance, constant questioning, anxiety, relentless doubt. Not doubt of the world, doubt of yourself. This is the first principle. This is where all genuine understanding begins. Feynman believed in approximate answers. He believed in probable truths and measured uncertainties. He distrusted anyone who claimed absolute certainty, because he knew that certainty is often just self-deception. That has gotten comfortable. The bamboo control towers are everywhere. In science, in politics, in business, in your own mind. But the planes only land on real runways. The truth only comes to those willing to do the work, willing to bend over backwards. Whoa. Willing to report the flaws, willing to welcome the criticism, willing to be wrong. This is the hardest thing, and this is the only thing that matters. Look around at the world. Look at the confident claims and the strong opinions, and the people who are absolutely sure they are right. And ask yourself, how many of them are standing in bamboo control towers, waiting for planes that will never come? Then, ask the harder question. Am I? If you can ask that question honestly, you have taken the first step. If you can keep asking it every day about every belief, you are practicing something Feynman would recognize. Not certainty, not knowledge, but something better. The willingness to find out. End of script. Closing visual.